So in previous unit we discussed about categories and characteristics of transients. Now we discussed about the long duration voltage variation. What is meant by long duration voltage variation? How we define the long duration voltage variation. So the long duration voltage variation means it is defined as long duration variation encompass root mean square, that means RMS, deviation at power frequencies for longer than 1 minute. That means more than 1 minute present the voltage variation, means up voltage, up means the swell voltage variation is called the long duration voltage variation. Specify that steady state voltage tolerance expected on a power system. So greater than 1 minute we will call it as a long duration voltage variation. A voltage variation is considered to be long duration when the ANSI limits are exceed for greater than 1 minute. Already we discussed. Long duration variation can be either over voltages or under voltages. The either may be, that is sag or swell. Greater than 1 minute we will treat it as a long duration voltage variation. So the long duration voltage variations, so having over voltage or under voltage. Long duration voltage variation is a over voltage or under voltage. So the variation of in RMS value of voltage at power frequencies for longer than 1 minute. This is a single line. So long duration variation can be either over voltages or under voltages caused by load variation, sudden fluctuation in a load. So by sudden increasing of load or sudden decreasing of load causes long duration voltage variation is occurred on the system and system switching operations. Such variations are typically displayed as plots of RMS voltage versus time. Outage. The term outage as defined by IEEE in Institute of Electrical and Electronics Engineering Standards refers to the state of component in a system that has failed to function. So the correct definition of outage we discuss later. The short duration voltage variation means energization of large loads which require high starting currents or intermittent loose connection in power wiring. Depend on the fault location and the system condition. The fault can cause either temporary voltage drops, voltage rises. Voltage drop means that is a sag, under voltage. Voltage rise is a swell. Component loss of voltage is a complete loss of voltage is an interruption. There is no voltage present in particular duration of time. Interruption. An interruption occurs when the supply voltage or load current decreases to less than 0.1 per unit for a period of time not exceeding 1 minute. Not exceeding 1 minute. Interruption can be the result of power system faults, equipment failures, and control malfunctions. The interruptions are measured by their duration. Since the voltage magnitude is always less than 10% of nominal, the duration of an interruption due to fault on the utility system is determined by the operating time of utility protective devices. Instantaneous reclosing generally will limit the interruption caused by non-permanent fault to less than 30 cycles. Delayed reclosing of the protective device may cause momentary or temporary interruption. So this is a interruption waveform. So the complete loss of voltage or current on a particular duration means so 1 to some 1.3, there is no voltage or current in present in this particular time. This is a interruption. So sags or dips. A sag is a decrease to between 0.1 and 0.9 per unit in RMS voltage or current at the power frequencies for duration from 0.5 cycles to 1 minute. A short duration voltage decreases is called as Sag. Voltage sags are usually associated with system faults but can also be caused by energization of heavy loads or starting of large motors. Figure below shows voltage sag waveforms. Please observe the sag waveform. So which is the sag? Please observe the voltage in 0.05 to 0.1. There is a sag in a voltage. Sag in a voltage. A transient with primary frequency component less than 5 kHz and duration from 0.3 to 50 milliseconds is considered a low frequency transient. The category of phenomena frequently encountered on utility subtransmission and distribution system. Oscillatory transient with principal frequencies less than 300 Hz can also be found on the distribution system. These are generally associated with ferro resonance and transformer energization. Interruption, sags, well sustained interruption. So the long duration voltage variation can be either over voltages or under voltages or sustained interruption. And over voltage is an increase in the RMS AC voltage greater than 110% by reference of CBEMA curve at the power frequency for duration longer than 1 minute. Over voltages are usually the result of load switching. The cause of over voltages are inadequate voltage controls, incorrect tap setting on transformers. And under voltage is decreases in the RMS AC voltage to less than 90% at the power frequency for a duration longer than 1 minute. Here the time duration is the 1 minute. The voltage fluctuation is 90 to 110, above 110, below 90% of voltage. The cause of under voltage is load switching on or a capacitor bank. Switching off can cause an under voltage. When the supply voltage has been zero for a period of time in excess of 1 minute, the long duration voltage variation is considered sustained interruption. So what is meant by short duration voltage variation? Greater than 1 minute we will treat it as a long duration voltage variation. So which is treated as a short duration voltage variation? The category encompasses the IEC category of voltage dips and short interruptions. Short duration voltage variations are caused by fault condition, the energization of large loads which require high starting currents, or intermittent loose connection in power wiring. Depending on the fault location and the system conditions, the fault can cause either temporary voltage drops or voltage rises or a complete loss of voltage interruptions. This is the short voltage variations.